Imagine a spaceship 60 kilometers long, capable of carrying 2,000 people heading toward Proxima b, the closest exoplanet located just over 4 light years away. This is Chrysalis, the winner of the Hyperion competition, a so-called generation ship. Because the journey would take between 250 and 400 years, this would be the first colonization of the stars. The news exploded in the Romanian press as well. Even my mother wrote to me, "Sir, is this really true?" People really believed it would happen soon, but that's how it is. On paper, this idea of sending a ship with colonists to the exoplanet Proxima b seems promising. After all, Proxima b is the closest exoplanet to us that we know is in the habitable zone. But be careful, the host star Proxima Centauri, so the star around which the exoplanet Proxima b orbits, is not an ordinary star. It's a red dwarf star, extremely violent. It produces solar flares, ultraviolet explosions, and X-ray storms that can destroy the atmosphere of any nearby planet. Moreover, most likely this exoplanet where the colonizers would want to go is also tidally locked. That means its rotation around its axis is synchronized with its orbital movement. This causes one side of the exoplanet to always face the star. So we have one hemisphere that's in the star's eternal light and the other in permanent darkness. This greatly reduces the chances of finding a normal atmosphere, a breathable atmosphere, possibly rich in oxygen. Also, let's remember something else. Oxygen on Earth was actually produced by life itself, over billions of years. In other words, what are the chances of finding it intact on that exoplanet, so that the colonists can breathe? After centuries of travel, colonists would likely find either a dead world or a hostile environment as it is. On Earth, with its nucleotides and precisely, attention, the 20 forms of amino acids, the astronauts have arrived there. I'm afraid they will feel condemned to death. Let's take a look at the ship now. Chrysalis would be a massive cylinder, 58 kilometers long, with a mass of 24 billion tons. It could theoretically accommodate 2,400 passengers. This cylindrical design is specifically chosen to reduce collisions with micrometeoroids. At 5,000 kilometers per second, even a tiny dust impact would cause irreparable damage to the ship. On the other hand, here's how I see it. Keeping a ship airtight for 400 years so it doesn't lose its oxygen is an illusion. Andre's Arctic balloon expedition is a lesson. If you haven't seen it, watch the movie on Netflix. He set off with a hydrogen balloon toward the North Pole, believing he would stay in the air for 30 days. In reality, the hydrogen was lost in a day and a half. Andre and his colleagues died. In my opinion, it's unlikely that such a large ship could remain perfectly airtight for centuries. Because if the atoms are lost, the travelers are lost. It's not like on Earth, where atoms are abundant. There, you watch them, you see them leave, and you feel sorry. And on the International Space Station, oxygen is lost too. However, there, oxygen is not brought from Earth, but is generally regenerated through electrolysis experiments or similar methods. But be careful, water is brought from Earth. So, who brings you water in space? Who anchor? And now, a bit about the propulsion of this ship, which has been talked about so much in the Romanian media. In my opinion, the propulsion is at the edge of science fiction. Chrysalis relies on fusion reactors with deuterium and helium-3 to reach speeds of 5,000 km per second. That means dozens of times greater than the most powerful rockets today. And of course, enough to cover the distance of several light years to Proxima Centauri. In a few hundred years, the speed is about 1% of the speed of light. We can understand the fusion process if we look here. Deuterium is an isotope of hydrogen with one extra neutron in the nucleus, and helium-3 is an isotope of helium with one less neutron. You can see the reaction and the energies of the resulting particles. Here is also the speed of the particles at those energies, which you can see is 1000 kilometers per second. Theoretically, if these reaction products are allowed to exit the combustion chamber, they will come out at speeds of 1000 kilometers per second, which is what we need. We also need to use a magnetic nozzle to direct them backward so that the rocket is pushed forward. So what's the problem? Well, if you want to accelerate a rocket to 5,000 kilometers per second with fuel ejected at 5,000 kilometers per second, the fuel needs to be half the mass of the rocket. You throw it out the back and you have thrust for the remaining half. The ejection speed will be, in this case, equal to the speed you get. Of course, once you reach your destination, you have to decelerate. That means another half of what's left of the ship has to be dedicated to fuel. So the habitable area is about a quarter of the ship's initial mass, roughly speaking. You have half, anyway, billions of tons of fuel, according to the calculations of those who proposed this project. And what's the reality? Well, the reality is that we don't even have controlled fusion for our own power plants. Magnetic nozzles capable of collimating particles with mega-electron volt energy. There is no deuterium, it is indeed found in the sea. But helium-3 is practically non-existent on Earth. On Earth, there are only a few dozen recoverable tons, while Chrysalis would need billions of tons. Alright, people say that we will extract this helium-3 from the gas giants in our solar system. Extracting it from gas giants like Jupiter remains, in my opinion, science fiction. Not to mention that the energy obtained from fusing those billions of tons of deuterium and helium-3 needed to propel the ship would be equivalent to the total consumption of humanity for 1,000,000 years. In other words, a huge amount of energy. The internal structure is designed like a matryoshka doll with concentric layers that rotate. Agriculture, the school park, printed homes, and so on. The areas would be lit by LEDs, but hey, LEDs only last a few years. We all know that. If you run out of LED bulb supplies, you need LED factories. But factories for semiconductors, microchips, mobile phones, medicines, and other things that break down. It's hard to imagine how many things you need when you're so far away. This highlights a point. Our civilization exists thanks to a global production network. The International Space Station barely survives a few months without resupply. How could this chrysalis manage on its own for centuries? A spectacular and perhaps even beautiful element of this ship is Cosmos, sir. That is a glass dome about 130 meters high for observing the stars. However, keep in mind it would be mounted at the back of the ship, so you can see the place we left from the sun, so people can remember where we came from Earth, from there. But the ship's engine jet will be in the same direction. Now, honestly, I don't know how much will be visible behind the ship. It would also have artificial gravity, which would be achieved by rotation. But be careful, this is not identical to Earth's gravity. Because if you stand on a rotating object, you'll experience the Coriolis force, and you'll also have effects on your inner ear. And in the long run, this can affect your health. Also, the ecological system is designed as a closed loop. They come to recycle water, the rocket, air, and nutrients, everything that's needed. However, this has never worked on a large scale. The Biosphere 2 project in Arizona from the 1990s, where they tried to create a closed ecosystem, failed in less than 2 years. Believing that the biosphere on this ship will work flawlessly for 400 years is, I think, a huge challenge, to put it mildly. And what about society on the ship? The plan is for the first generations to be trained in isolated bases in Antarctica for 70 to 80 years. But the Antarctica has evacuation and supply routes in space. There's no way out. Moreover, I think about it, on Earth we have wars and revolutions, and that's even with plenty of resources. How could a small GRU remain stable and united for centuries, with no resources other than what the ship has, locked inside a metal cylinder? And even worse, What right do we have to condemn entire generations, not even born yet, to such a fate? Maybe they won't consent. In the end, personally, Chrysalis is a project for students. I mean, sir, whoever has a good idea to build a ship, and this project won. They won it fair and square because for a student project it was pretty good. However, I don't think this Chrysalis is actually a real roadmap, but more of a little student fantasy. It underestimates the dangers to the planet. Proxima b assumes technologies that don't exist and relies on inaccessible fuel. It ignores the impossibility of recreating a global civilization on a single ship and overlooks the psychological realities of isolating people on Earth. This vision is spectacular. The student idea is cool, but I don't think it's realistic. In fact, I actually find it quite misleading. I think if this project brings anything to light, it's how interconnected we all are here on Earth. We truly have a global civilization. We depend on each other. Whether we're in China, Romania, or America, we live on a planet we've adapted to. I say we should appreciate that. Dear friends, that was today's video. If you haven't subscribed yet, click the subscribe button now. Write in the comments what similar topics you would like. Give a like and share if you enjoyed it. It helps me out. Until next time, I'm Christian Presura, Physics Explained. You're cool. All the best. Goodbye.